AND function or AND operation using a. What about defining a AND function or AND operation using a logistic regression or a single perceptron? How can we define an AND function? So we have a line and we have the value of x1 and x2. So for all combinations of x1, x2, because we have only two variables, we will have 4 combinations, right? 0, 0, 0, 1, 1, 0, and 1, 1. And how can we define those values? This point is 0, 0, 0, 1, 1, 0, and 1, 1. And what does an AND operation do? For all values, it is 0. We already know this. And only if they are both 1, we have output 1. This is your AND function. So this is fairly simple. Right? We define our W1 and W2 and W1 in the equation. Simply put the value of W's such that you get these values. So these are the suitable values of W1, W2 and W0. So if I put the value of these W's into this equation, let's see, if x1 is 0 and x2 is 0 and W0 is minus 1.5 plus W1 into your x1, it will become 0. Then W2 into your x2, it will become 0. And what is it equal to? The summation, that is equal to minus 1.5, right? Summation. And then what our function did? Okay, if summation of them is greater than 0, then only we say it is 1. So our summation is minus 1.5. It is not greater than 1. So we say y is 0. What about 1, 1? Okay, W0, this is for 0, 0, x1, x2. This is for 1, 1. Okay, so minus 1.5 plus W1 is 1 multiplied by 1 is 1. Then W2 is 1 and your x2 is 1, which is and the sum is equal to Wixi is 0.5. Now revisit this equation. So if it is greater than 0, okay, yes, it is. 0.5 is greater than 0, so we have an output of 1. We can set the required values of your W's to design an AND operation. So here in this example, our perceptron was used to develop an AND operation. So for 0, 0, your output is red. Then 0, 1, it is red. 1, 0, it is red. And for 1, 1, it is blue. So this is your AND function designed using a perceptron. What about OR operation? Can we define OR operation using a perceptron? Similarly, we have defined W1, X1, a simpler function to get you started with the concept that we can define different functions and perform different operations using perceptrons. So similarly here we have to find the suitable value of w's that can be used to define or operation. So for 0 0 in the same equation, we put the value of x1 and x2. W naught is minus 0.5 plus w1 into x1 0, w2 into x2 is 0, and the output and summation of these wi's and xi's is 0. So again summation is minus 0.5. Let's look at the function. So if the summation is greater than 0, only then we can assign a 1 to y. So for this first input, we will have y equals to 0. Let's test for this. Today we are going to study the